everyone. We're going to express our improper integral as a limit of definite integrals and evaluate the integral. Before we get started, I just want to take this and look and see what we have here. If you let u equal x squared plus 1, then du would equal 2x dx. So I could write this indefinite integral as du divided by u squared. And if you integrated this, you're going to get, this is u to the negative 2 power. So it's going to end up being negative 1 divided by u. And then when you substitute it back in, you're going to get this equals negative 1 divided by our u, which is x squared plus 1. Just get that out of the way. So that's what we're going to be doing when we integrate. So now we have this form here. We're going from negative infinity to infinity. And so the first step we have to do is express this improper integral as a limit of definite integrals. And what we're going to do is let b equals 0. So when you write this out, we're going to write it out as the limit as b approaches negative infinity. And we're going from b to 0. That's this part of our f of x, which is 2x divided by x squared plus 1 squared dx, plus the limit as b approaches infinity, and this is from 0 to b of our f of x, which is 2x divided by x squared plus 1 squared. My 2's don't show up very well. All right. So that's the first part that we had to do. Now we have to evaluate it. So when we evaluate it, we're going to write this as the limit as b approaches negative infinity. And you integrate this, which we already did right here. So this is going to be negative 1 divided by x squared plus 1. And we're evaluating it from b to 0, plus the limit as b approaches infinity. And we have negative 1 divided by x squared plus 1. And this is from b, we're valuing from 0 to b. Now, when you evaluate this, when you plug in 0, we're going to get, this is the limit as b approaches negative infinity. And we're going to get, when you plug in b, we'll just plug in 0 first. That's going to give you negative 1 minus, when you plug in b, you're going to get, so it's going to end up being plus 1 divided by b squared plus 1. All right, now for this side, you're going to get the limit as b approaches infinity. And when you plug in 0, or b, you're going to get negative 1 divided by x squared, which is b squared, plus 1. And then we're going to have a plus 1 here when you plug in the 0. You minus the negative. All right. So what happens is when you plug in infinity, this number is going to get very large. So this number really doesn't matter. This doesn't matter. So basically we're going to have 0 plus 0. So the limit is going to equal 0. Again, when you plug a really large number in the denominator and it's larger than your numerator, then that's going to get closer and closer to 0. So that is your limit. Thank you. Have a nice day. Bye-bye.